Hello students, this is Dr. Ben. Today we'd like to work on a problem out of the middle part of chapter 4 that has to do with kinematics and forces together. So we take a look at this problem and we can see that it involves vertical motion. So it's describing an elevator that is moving, it's actually slowing down. And we're given some information about its motion, and we're asked to find something about the tension in the cable as the elevator speed is decreasing. So it looks to me that we have a lot of information about the motion of this problem. So in terms of a strategy, I think that this should be a motion first problem, and we can use that information to find the acceleration of the elevator. And then we can consider the forces part of the problem. So the forces part second, where we can use Newton's laws in this acceleration to help us find the tension. So not all force and motion problems are work this way, but this particular one seems like it is a motion first type. So let's go ahead and make a list of what we know from the problem information. So the mass of the elevator is given to be 1,000 kilograms. The initial speed of the elevator is upwards. Let's call that point number 1. So that's going to be 6.0 meters per second. And then the velocity when the elevator comes to rest is going to be 0. We'll call that point number 2. And we're told that this time interval for the motion to change is 3 seconds, and that we're supposed to use the value of g to be 10 meters per second squared. Alright, so let's go ahead and draw a pictorial representation of this so we can analyze the motion part of the problem. So let's put that pictorial representation on a vertical axis. Let's call the positive direction as upwards and the origin down there towards the bottom. And for convenience, why don't we put the elevator at the origin for the initial spot and then at a higher location for the final spot. So we'll call that point number 1 and point number 2. And between those 2 points there is acceleration that points downwards because the elevator slows down. So let's define our motion variables. So we'll have y1, v1, and t1. And we can have y2, v2, and t2. And it seems reasonable that we can start our coordinate system for time at 0. So let's set t1 equal to 0, and so that implies that t2 would then be equal to the 3 seconds that are given. Alright, so I think we've got enough information now to go ahead and solve the motion part of the problem, and we need to the kinematic equation that would be most useful. So since we know something about the time, it makes sense to use one of the 2 equations about the time, and we know a lot about the velocity, so the equation with the velocity and the acceleration in the time is probably the most useful. So we would write that down as v2 equals v1 plus the acceleration times t2 minus t1. And the only quantity that we don't know in that expression is the acceleration. So it's probably quicker to do this numerically. So v2 is equal to 0. v1 is equal to plus 6 meters per second squared, but meters per second in our coordinate system. The acceleration is what we want to find. t2 is 3 seconds, t1 is 0. So if we solve this expression for the acceleration, let's take the 6 to the other side. So we get negative 6.0 equals a times 3.0. And then acceleration would be equal to negative 6.0 divided by 3.0, which is negative 2.0 meters per second squared. So that's going to be the acceleration of this elevator as it slows to a stop as it's rising. Okay, so now that we figured out that part, we can do the forces second to use Newton's second law in order to find the tension. So we need to draw a force diagram for the elevator. So, we'll represent the elevator by this box and dot at its center of mass. We'll draw the forces that act on the elevator. So there should be the tension in the cable that points up, and there should be the weight of the elevator that points down. The acceleration of the elevator is down, and I'm going to pick a coordinate system where positive y is upwards to do the force part of the problem. So Newton's second law tells us that the acceleration is equal to the net force divided by the mass. So if we apply that to the elevator, we would say that A equals the quantity, the tension minus the weight divided by the mass. And we can solve this expression for the tension. So if I cross multiply, I get m times A equals T minus m times G, or T is equal to ma plus mg, which actually I can simplify by factoring out the mass into A plus G. Alright, and now we can plug in the numbers that we have. So the mass is 1,000 kilograms. The acceleration we found in the first part of the problem to be -2 meters per second squared. Then the acceleration due to gravity has a magnitude of 10. We already took its direction into account by on our force diagram. So we have 1,000 multiplied by 8, which is equal to 8,000, and that should be newtons. So the tension in the elevator cable is going to be 8,000 newtons, and just as a conclusion to the problem, we'll make sure that we put our units of measure, which were newtons because we found a force, and our significant figures. It's a little bit hard to tell how many there are in the mass, but the numbers come out to be 8,000 in this particular problem. Alright, so there we have an example of combining force and motion concepts together.